So let's take a DS question on number properties. You can pause the video for 2 minutes and then can resume. The question is, if root X students were absent on Susie's class and more were present than absent, how many were present? So there are two things. One, number of absent students is equals to what? It is root X. And second is number of students who are present. Say number of students present is P. So number of students present is greater than number of students absent, which is given equals to root of X. So we have to find out the value of P. With this in mind, let's see statements one by one. Statement 1, if a total of X plus root X students enrolled for the course, it means P plus A is equals to X plus root X. We already know that A is what? Root X. This is given number of students absent is equals to how much? Root X. So P plus A equals to X plus root X. It means this gives what? P is equals to X. But this itself is insufficient. We can't find out the unique value of X. So we'll have to move to statement 2. This is insufficient. Now statement 2, fewer than 12 students enrolled for the course. So we can say P plus A is less than 12. And we already know that A is what? Root X. This again doesn't seem to provide any value, unique value of X. But since this is less than inequality, so we should definitely consider this, because hardly less than 12 means what? 1, 2, 3 up till 11 values are under the consideration. And one more thing about root X is that since number of students absent will be what? Non-negative integer. That means root X must be what? Perfect square. So given this information in mind, let's see if we put X is equals to 0. If we put X is equals to 0, we get P is equals to what? Less than 12. It doesn't help because P can be what? 1 till 11, any kind of a value. This itself is sufficient to prove that statement 1 is insufficient. We can still probe further. If X is equals to 1, again a perfect square value. So this is 1. So P is what? Less than 11. Again P is what? 1 to 10. So this is insufficient. So we are left with what? Combining both the statements, 1 plus 2. So 1 plus 2 we combine, X plus root X. This is the total number of enrolled students, X plus root X. And from statement 2 we know that this is less than 12. And we have to now make sure that number of present is greater than absent. Number of present, here we already got X. So X is greater than root X. Keeping these things in mind, what? X is greater than root X. X is a perfect square number. Let's see. Take these two values because earlier we already have worked on that. So X is equals to 0. If X is equals to 0, then this is 0, this is again 0. These two are equal. Not valid value, because this fact will be invalidated then. So this is not possible. X is equals to 1, again a perfect square. Root of X is 1. 1 plus 1. But again these two values, root X and X, are equal. This will invalidate this. This is again not possible. Third is X is next perfect square value is what? 4. So it will be 4 plus root 4 is equals to 4 plus 2 is equals to 6. 6 is less than 12. Yes, this is the good contender. So let's keep this in mind that x can be 4. Let's move to another perfect square value of x. X is equals to what? 9. So with this equation, 9 plus root 9 is equals to 9 plus 3 is equals to 12. But this is not less than 12, this is equals to 12. So this is not a contender. So we are left with only one value of x, and which is x is equals to 4. So P is what? 4. The correct answer is C. Now the learning in this question is that you have to comprehend or infer that root x can be root x has to be integer, and that too a non-negative integer and perfect square. Otherwise you may falter on this question. Second is, did you incorporate the understanding number of students present is greater than number of students absent? With these two in mind and setting up the equation, this can be a good learning question